Hello viewers, you are welcome back again to my channel, Second Matter, the solution to your math problems. This is lesson 7 of indices. So in this lesson, we are going to solve some past questions on indices, some WASI past questions. So beginning with question 4a, we have to simplify the square root of a fractional index. So for the fraction, the numerator is 8 squared multiplying 4 exponent n plus 1 with the denominator 2 exponent 2n multiplying 16. So this is what we are going to do. We are going to simplify all the expressions inside the square root first. So all the expressions inside the square root will be simplified first. But to do this, can we write 8, 4, 16 and then 2 to have the same base? Yes, you can see that the common base here is 2. So let's do that. Let's rewrite all the numbers to have a single base. So 8 could be written as 2 exponent 3. So multiplying the 2, then times 4 in indices or in index form can be written as 2 exponent 2, and this will multiply n plus 1. So that is for the numerator. So for the denominator, we already have 2 exponent 2n. So there is nothing we will do here. But for the 16 could be written as 2 exponent 4. So all these expressions inside the square root sign. So we can see that we can simplify the index. So let's do that. 3 times 2, that is 6. And then when we expand, 2 multiplying n, that is 2n. 2 times 1, that is 2. So for the denominator, we just repeat them. 2 exponent 4. All these expressions inside the square root sign. Now the next step, we are going to write the numerator as a single index as well as the denominator. So now, recall from the first law of indices that anytime the bases are the same and they are multiplied, what do? We write one of the bases, but this time we add the index. So the first index here is 6 plus the second index 2n plus 2. So for the denominator, the bases are the same, they are multiplying. So again, we write one of the bases and then we add the index. Remember, all these expressions are inside the square root sign. Let me get a space here. So now we can simplify the index. So 2. So 6 plus 2, that is 8 plus 2n. So that is for the numerator. And for the denominator, we still have 2n plus 4. Again, they are all inside the square root sign. Now, can we write this fractional index as a single index? Yes, we can do that. Again, the bases are the same, but this time they are dividing. So from the second law of indices, when the bases are the same and they are dividing, what do? We write one of the bases, and this time we subtract the index. So the second index, 2n plus 4. Inside the square root sign, remember. So we can simplify the index. So let's do that. So we have 8 plus 2n. So when we expand the bracket, we have minus 2n minus 4. So let me repeat this. 2 exponent 8 plus 2n minus 2n minus 4. So let's simplify the index. You could see that some of the index will cancel out. Some of the index will cancel out. So 2n and the minus 2n will cancel out, leaving 8 minus 4. So 8 minus 4, that is 4. So we have 2 exponent 4 inside the square roots. And we can do away with the square root sign. Recall from the fractional index, the square root of a number is the number exponent half. So this could be written as 2 exponent 4 multiplying half. So 2 exponent 4 multiplying half. We can cancel out. 2 goes here 1, 2 goes here 2. So we are left with 2 exponent 2. And 2 exponent 2 is simplified as 4. So the right answer to WASSCE June 2014 objective is option C. Let's also look at the B. Okay, let's also look at the B. So for the B, we have to simplify this algebraic fraction. So now, recall from the negative index property of indices. So x exponent negative 1 can be written as 1 on x. So plus y exponent negative 1 can also be written as 1 on y. So this divided by x plus y. Now again, this whole expression can also be written as 1 on x plus 1 on y divided. Okay, also with the B. So there's a past question which came in WASSCE June 2018. So we have to simplify the algebraic fraction with the numerator x exponent minus 1 plus y exponent negative 1. And then for the denominator, we have x plus y. So now let's focus on the numerator. Recall from the negative index property of indices that x exponent minus 1 can be written as 1 on x, and then y exponent negative 1 can also be written as 1 on y. So all divided by the denominator, which is x plus y. Now again, this fractional algebraic expression can also be written as so this is for the numerator divided by the denominator, which is x plus y. So let me repeat this. So now let's simplify the numerator further by finding the LCM. So what is the LCM? So the LCM here is xy. X goes into xy, so the x will cancel out, leaving y. Y multiplied by 1, y. And also y goes into xy, So the y will cancel out, leaving x, and then x multiplied by 1, that is x. So for the numerator, we are going to use a simplified form. So let me get a space here. So the simplified form here is y plus x. And y plus x is the same as x plus y, because addition is commutative, divided by xy. And all of this expression also divided by the denominator, which is x plus y. Now, if I ask you to divide these two numbers, 2 and 3 divided by 5, how will you solve this? So first of all, we are going to maintain the first number, change the division sign to multiplication, and we find the reciprocal of 5, which is 1 on 5. So applying the same concept here, we maintain the first algebraic fraction. So x plus y divided by xy. Then we change the division sign to multiplication. We find the reciprocal of x plus y, which is 1 on x plus y. So let me repeat this expression. We have x plus y on xy, then multiplying 1 on x plus y. So we could see that some of the expressions can cancel out. So x plus y and x plus y will cancel out, leaving 1 on x, y. So from the alternatives, what should be the right answer? So the right answer is option C. So this brings us to the end of lesson 7 on indices. Please like, comment, and share the video. See you next time.